Our first example on proving trigonometric identities is actually taken from an Add Maths past paper question. CSEC Add Maths May-June 2014, paper 2, number 4, part C. We want to prove that tan theta sine theta divided by 1 minus cos theta is equivalent to 1 plus 1 over cos theta. Now, anytime I'm faced with proving a trig identity, I like to brainstorm a little bit from the very beginning. Before I put pen to paper, I like to come up with a roadmap, if you will, in my mind as to how I am going to get from the left-hand side to the right-hand side. So I'm going to start by taking the left-hand side, tan theta sine theta divided by 1 minus cos theta, and it may take me 3 steps, it may take me 10 steps to get to the right-hand side. At the end of the day, this question is only complete once I can show that tan theta sine theta divided by 1 minus cos theta is equivalent to 1 plus 1 over cos theta. So I'm going to continue working until I get that right hand side. So throughout working this question, we must keep an eye on the right hand side because that is what we have to end up with. So what I'm thinking right now is that the only thing I can do on the left hand side is substitute in place of tan theta sine theta over cos theta. When I multiply that by sine theta, tan theta sine theta becomes sine squared theta over cos theta. So that is my numerator, and my denominator remains as is, 1 minus cos theta. Now, whenever I have a fraction in the numerator, what happens is that the denominator of that fraction goes down in the bottom line. So if you recall, for example, a half divided by 3, we have a fraction in the numerator, and a half divided by 3 is 1/6. In other words, the 2 from the numerator, which was a half, goes down into the bottom line. So a half divided by 3 becomes 1 divided by 2 times 3, and that's how we get 1/6. So by the same principle, sine squared theta over cos theta divided by 1 minus cos theta becomes sine squared theta over cos theta, open bracket, 1 minus cos theta. Now that sine squared theta on top, I can replace it with 1 minus cos squared theta, because I know that sine squared theta plus cos squared theta is equal to 1. So I can replace the sine squared theta with a 1 minus cos squared theta, and somehow something from on top has to cancel with the 1 minus cos theta on the bottom for me to end up with 1 plus 1 over cos theta. So after all of that talking, I'm going to put pen to paper and you will be able to visualize what I just said. So we start by taking the left hand side. Good. I'm going to work that down all the way until I end up with what is on the right hand side. So tan theta, I'm now going to replace that with sine theta over cos theta by sine theta. So tan theta sine theta becomes this on 1 minus cos theta. Next, sine theta over cos theta by sine theta is just sine squared theta on cos theta. So I have a fraction in the numerator and then I have 1 minus cos theta in the denominator. Next line. This is what I was saying. We have a fraction in the numerator. The denominator in this fraction comes down to the bottom. So sine squared theta divided by cos theta times 1 minus cos theta. That's my next line. So here I have the cos theta. Remember, I want to end up with 1 plus 1 over cos theta. So I'm seeing the cos theta in the bottom. This 1 minus cos theta does not appear on the right hand side, which is what we're trying to get. So we need to get rid of this somehow. So this must cancel with something up here. Sine squared theta, we know that's the same as 1 minus cos squared theta. So I make that substitution there. And something in 1 minus cos theta must cancel with something in the numerator. So I have to do something here. 1 minus cos squared theta. Again, quadratics always comes into play. Recognize the difference of squares. 1 minus cos squared theta is the square of 1 minus the square of cos theta. So both 1 and cos squared theta are what we call perfect squares, and they are separated by a minus sign. So recognize 1 minus cos squared theta as the difference of squares. It will factor like this: 1 plus cos theta by 1 minus cos theta. And now we can see what is going to cancel out with this 1 minus cos theta. Here it is. And I am going to end up with 1 plus cos theta divided by cos theta. So I am very close now to getting that final line. What I'm going to do now is split this single fraction into two separate fractions because they have a common denominator of cos theta. So I can rewrite 1 plus cos theta over cos theta as 1 over cos theta plus cos theta over cos theta, and I'm going to do that now. So the next line is that it's equal to 1 over cos theta plus cos theta over cos theta, and the rest is elementary from here. I will have 1 over cos theta plus cos theta over cos theta is 1, and I will just rearrange it into the form that we want to get the right side into, and there I have 1 plus 1 over cos theta. So again, it does not matter how many steps you take to get from the left hand side to the right hand side, as long as every step is legitimate. It really does not matter. You take your time and you get there. Proving a trig identity is a very abstract topic. There is more than one way to do any particular example, and no two examples are alike. So it is a very, very difficult topic to teach. It's really something you can only master by doing a lot of examples. Like most things in mathematics, but particularly an abstract topic like proving trig identities, it's something you have to put pen to paper and you just have to solve as many questions as you can. Remember, always from the beginning, try to create a roadmap in your mind as to how you're going to get from the left hand side to the right hand side. Do not just start doing the proof not having a clue how you're going to get from the left to the right hand side, because most times you're going to end up getting confused. You're going to reach a point where you don't know what to do, and then you're going to have to scrap the question and start all over again. So always make sure that you think the question through from the beginning before you start putting pen to paper.